Good morning, students. So today I am going to explain you about electric flux. Electric flux. We already have discussed about electric field in our classes. And what is electric field? For knowing about electric flux, it is very important for us to know about electric field. So electric field is actually the property of a location. So students, whenever we are defining electric field, it depends on location. It depends on location, or we can also say that electric field is the characteristics of a location. Then what is electric flux? Electric flux is the characteristics of electric flux is the characteristics of an area. We can say it depends on area, so it is the characteristics of an area, or we can also define as the number of field lines, the number of field lines linked to a surface is known as electric flux. Known as electric flux. Electric field is a vector quantity, while electric flux is a scalar quantity. I will explain you with one example. Suppose, firstly I am drawing the electric field. So, suppose we have electric field in this way. Say this is figure A, and now I am drawing figure B. This is electric field somewhere in any location, and this is another electric field in any other location. Say this is the electric field, this is in location A, so I am naming as EA, electric field of location A. And this electric field is in location B, so I am naming it as electric field B, EB. Now, suppose I have to check the intensity of electric field for particular area. अगर मान लीजिए इस पर्टिकुलर एरिया पर हमारे पास कोई सरफेस है, तो सरफेस से कितनी फील्ड लाइन पास होंगी, दैट वी हैव टू चेक इट आउट. सो व्हाट आई एम डूइंग करंटली, आई एम कीपिंग वन particular area. In this, firstly I have kept it in location A, and the same area I am keeping in location B. The similar area I have kept in location B. Now, okay, this is area A, or we can name it as DS. We can name it as DS. DS we are denoting because it is surface area, and small surface we are keeping, so I am naming as DS. Now it is very clear, अगर हम देखें यहाँ से इस DS के लिए कितनी नंबर ऑफ फील्ड लाइन पास हो रही है, so we will count as 1 2 3 4 5. So here we can say the number of field lines which are passing through the figure A is 5. When the number of field lines which are passing through figure B is only 1 and 2 only. So among these two, figure A and figure B, which is having more flux, so we can simply say that this figure A is having more flux. How we define it? So already I have written the definition for it. The number of field lines linked to a surface is known as electric flux. So the number of field lines which are linked to this surface is known as electric flux. Here it is very greater, and here it is very small. Now we can understand that why electric flux is considered to be a scalar physical quantity. So for understanding it, we can take any other example. Suppose I have a pipe and from that pipe water is coming out. Water is coming out, and I have kept one container here and another container here. So water is coming and water is having a particular direction. So water is here, the water is vector. Because this water is having particular direction. So direction this water is going to get. So whatever physical quantity which is having certain direction is always the vector. So this water is a vector. Now when I kept another pipe here, okay, for container A as well as and for container B. Now what will happen? When we will place this, then water linked to this pipe will keep on entering here. And when water will keep on entering here, it will be filled in this particular container. So by this example, we can understand that the quantity of water, students, please pay attention, the quantity of water here which will enter depends on two things. One is the intensity. Intensity we can also say velocity. Means higher the velocity, higher will be the velocity of water, greater amount of water will be entered here in figure A. Now lesser is the intensity, lesser the water will be entered. And on one more thing, this is depending on, and that is area of this particular pipe which is actually receiving it. So greater will be area, more will be the water entered in this particular container. In the similar way, suppose I have kept a little greater pipe. So what will happen? More water will be entered here. Why more water will be entered here? Because it is having greater area as compared to figure A. So we can say that the water entered here depends on two things. One is intensity and another one is the area. In the similar way, electric flux also depends on two things. One is the electric field intensity and another is the area. Higher will be the area, greater the electric field lines will pass through the surface, and lesser is the area, the lesser number of field lines will pass through the surface. And why flux is scalar one? Because you can clearly understand from this example, the water which was coming out was having particular direction. So it was a vector. Okay, and when water is kept here in the container, it is having no direction. It is just a quantity, and this is having no direction. This is having no direction. So this amount of water which is here, we can say that is flux for understanding it. Okay, and the water which was coming in this way was electric field. So electric field is having certain direction, and when it is passed through a surface, that is having no direction. So this is how we understand it. And what is flux? Flux is always denoted by phi. Okay, and whenever we are denoting it by phi, and phi is actually depending on two things. Already I have explained to you that it depends on, flux depends on two factors. One is area and another one is the field intensity. So flux is the dot product of electric field and the area. Say the surface area linked to this particular electric field is ds, then flux is E dot ds, and whenever there is a dot product, A dot b is equal to AB cos theta. So phi is equal to E ds cos theta. Here theta is the angle between this surface and electric field intensity. Later in the lecture of Gauss theorem, we will understand that where theta is located. In my next lecture, I am going to explain you this. So thank you.